Okay, welcome back to lesson 3.3. In this section, we're going to do two examples, and we're going to kind of practice determining whether two triangles could be congruent from some given information. So for each of these examples, we're going to determine if the pair of triangles are congruent or if there's not enough information. And we're going to practice fully justifying our answers. So if we want to say that the triangles are congruent to each other, we're going to give a reason why each pair of corresponding parts must be congruent. So if we're doing this, we need 6 reasons total, because there are 6 pairs of corresponding parts. There's 3 pairs of sides and 3 pairs of angles. If we want to say that there's not enough info, we're going to state which pieces of information are missing. So which pairs do we not know about? Okay, so let's look at our first example. We're given some information, and then we want to know if triangle QRS is congruent or an exact copy of triangle UTS. Okay, so let's just go through and see what we know, see if we can write down pairs that would be congruent, and if we get all 6, then we can say congruent. If there are some where we're like, I don't know if we know this, then we have to say not enough info. Okay, so let's just start with what we're given. We're first given that QR is congruent to UT. So if I was marking that on the figure, I would put a tick mark there. And I can write this down. And my reason for that was just given. We were just told that. You always trust what the given says. Okay, our next piece of information says that S is the midpoint of RT, so this segment, and QU, this segment. And remember, midpoint means exactly in the middle. So it's splitting those segments into 2 congruent parts. Okay, so S is in the middle of RT, or RT is split into 2 congruent parts, so I know that this chunk is the same as that chunk. So we know RS is the same as TS. It's also the midpoint of QU, so we know that's split into 2 congruent parts, so QS is the same as US. Oops. And our reason for that is that S is the midpoint of RT and QU. So I got 2 pairs from the same reason there. That's okay. Because there's really like 2 reasons embedded in this. S is the midpoint of RT, S is the midpoint of QU. All right, let's see what else we know. So we've got all the sides. Can we get some angles? And I see a pair of vertical angles right here, so we know that those are equal to each other. So I know that angle, let's see, remember we use 3 letters to name an angle, and the vertex has to go in the middle. So outline the angle with your letters. R to S to Q is congruent to angle T to S to U. And the reason for that is vertical angles. Okay, and then the last thing I'm noticing about this figure is that we have parallel segments. So that's going to tell me that angle U is congruent to angle Q because those are alternate interior. And the same thing with angle R and angle T. Those are also alternate interior. So angle Q congruent to angle U, angle R congruent to angle T by alternate interior. All right, so we got all pairs of sides and all pairs of angles are congruent to each other. So this means that our triangles are indeed congruent. They're exact copies of each other. And we can say that, yes, triangle QRS is congruent to triangle UTS because they are exact copies. They have 6 pairs of congruent corresponding sides, or parts, sorry. All right, let's try one more of those. So in this one, we're given that triangle TRG, so TRG, this big triangle is isosceles, and that TG is the base. And then we want to know if triangle TRL, so this little triangle here, is congruent to triangle GRL, so this little triangle. So let's see what we can get. We know that isosceles triangles have 2 congruent sides and 2 congruent angles, right? That's what the isosceles triangle theorem says. And let's see, the angles that are congruent are the base angles. So if TG is the base, our congruent angles would be angle T and angle G. And then the sides that are congruent are the legs, the not base sides. So we would have TR and GR. Okay, so let's write that down. Angle T congruent to angle G, TR congruent to GR. And these both came from triangle TRG is isosceles. Okay, what else do we know? Well, we know that this angle is 90, RLG, and then if that angle is 90, the angle on the other side also has to be 90 because they're a linear pair, so they add up to 180. 180 minus 90 is 90. Okay, so that's telling me that angle RLG is congruent to angle RLT because they're both 90. All right, and I think we know one more thing. So this is a little bit weird, but these triangles actually share a side, right? RL is shared between them. And RL is obviously the same length as itself. So we can actually say RL is congruent to RL. And this has a fancy name. It's called the reflexive property. But it's basically the idea that things are congruent to themselves. All right, so let's see. We have 1, 2, 3, 4 out of our 6. Can we get the other 2? Well, I don't see anything here that would tell me for sure that those 2 angles are congruent. That's our other pair of corresponding angles. They sure look congruent, but there's nothing in this problem that's telling us that for sure. And I don't know about these sides. There's nothing in this problem that's telling us that those 2 bottom sides, TL and GL, are for sure congruent to each other. So let's see. Angle TRL congruent to angle GRL. That seems to be missing. Let's see. And a reason for TL to be congruent to GL is missing, right? Okay, so since we have 2 sets of corresponding sides, or corresponding parts, that don't have reasons to be congruent, we have to say that we don't have enough information. It might be that those things are congruent to each other, but we don't know. We don't know that they're not congruent, but we don't know that they are congruent for sure, beyond just what the figure looks like. So we have to say we don't have enough information. We're not going to conclude that the triangles are not congruent. We're just saying we don't know from what we've been told. And the missing information are those 2 pieces. Okay, so that's a way you can analyze whether two triangles would have to be congruent or not from a set of given information. And this type of analysis is going to lead us into doing proofs about congruent triangles in our next couple lessons.